Welcome to lesson 3 of tutorial 4, Matrices and Systems of Linear Equations. So we are going to continue with question 7, find the inverse matrix of the following using two methods, Adjoint Method and ERO Method. Okay, so let's start with the first method, Adjoint Method. So for Adjoint Method, firstly, write the formula. So A inverse equals 1 per determinant A times adjoint A. So this is the formula for adjoint method. So based on this formula, the first step is we need to determine the determinant. And since there is no zero in the element, we can choose any row or any column. So I will choose the first row. And remember, the sign of cofactors in the first row is positive, negative, and positive. And the cofactor signs will go alternately, starting from positive, negative, positive, negative, positive, negative, positive, negative, and positive. So determinant of A is positive 1 times the minor 1, 1 is 5, 9, 1, negative 2, minus 2 times minor 1, 2, 3, 9, 1, negative 2, and then plus 5 times minor 1, 3, 3, 5, 1, 1. So from here, you will have 1 times negative 19 minus 2 times negative 15 plus 5 times negative 2. And the answer is 1. Okay, the next step is to find the adjoint matrix. So adjoint A is the cofactor transpose. So for this step, I need a big bracket. So start from positive minor 1, 1, 5, 9, 1, negative 2, and then negative minor 1, 2, 3, 9, 1, negative 2, and don't forget the symbol T at the top because we need to transpose the matrix. So calculate the value. You should get negative 19, 9, negative 7, 15, negative 7, 6, negative 2, 1, negative 1. And then you transpose this matrix, you will have negative 19, 15, negative 2, 9, negative 7, 1, negative 7, 6, negative 1. And then the final step is substitute into the formula. So A inverse is 1 per 1 times with your adjoint matrix. So just copy back your adjoint. And since your determinant value is 1, you will have the same answer for A inverse and adjoint matrix, and that is a coincidence. So write your final answer. So that is your final answer. So we have done the adjoint method. There are 3 steps in adjoint method. The first is find the determinant. Second step is find the adjoint matrix, which is the cofactor transpose. And the third step is substitute into the formula. And that's it, you are done. So next we are going to proceed with the next method, ERO. So by ERO method, so this is quite a long method. So firstly, you have to write in terms of augmented matrix, which is the matrix A at the left side and identity matrix at the right side. And then finally, the position will change, which you will get identity matrix at the left side, and at the right side you will have the inverse of A. Okay, so this requires a few steps. So I'm going to write in augmented matrix first. So 1, 2, 5, 3, 5, 9, 1, 1, negative 2. Hopefully I don't forget the negative. And identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so the first step, we are going to change all elements in A to become the identity matrix, which the identity matrix is 1, 0, 0 in the first column. Okay, since the first element is already 1, so we don't need to change anything. So I'm going to change 3 into 0. How do we change 3 into 0? So row 1 is your reference row. So row 2 new. Okay, how do we change 3 into 0? Should be 3 minus 3, right? So to be 3 minus 3 is row 2 minus 3 times row 1. Right? So I'm going to fix the row 1. Okay. So fix the row 1. So next number 1. How do we change 1 into 0? Okay, so row 3 new. To make 1 into 0 is 1 minus 1. So row 3 minus row 1. Okay, so I'm going to use another color to show you the operation. So let's start with row 2. Row 2 minus 3 row 1. So I'm going to write all the elements in row 2 is 3, 5, 9, 0, 1, 0. Okay, minus 3 times row 1. So row 1 is 1, 2, 5, and then you have to multiply with 3, which then give you 3, 6, 5 times 3 is 15, 1 times 3 is 3, 0, 0. So then minus, you will have 0, 5 minus 6 is negative 1, 9 minus 15 is negative 6, 0 minus 3 is negative 3, 1 and 0. And this is your new row 2. Okay, so this is your new row 2. So how about row 3, new? Right. So we are going to write back row 1 because that is fixed and nothing changed. So what is your row 2 new? 0, negative 1, negative 6, negative 3, 1, 0. Okay, so for row 3, you can use the same method, or you can just minus the operation. 1 minus 1 is 0. 1 minus 2 is negative 1. Negative 2 minus 5, negative 7. 0 minus 1, negative 1. 0 minus 0 is 0. 1 minus 0 is 1. Okay? So this is done. So next step is to change the second column. So to change the second column, we will focus on number 1 first. Okay? So the number in the middle should be 1. So how to make that 1? The operation is negative 1 times row 2. Okay? So what happens when negative 1 times row 2? The other two rows is the same. So write back the other two rows. So this one is 0, 1, 6, 3, negative 1, 0, 0, negative 1, negative 7. Alright, so now we have 1 in the middle. So I'm going to fix the second row. So we're going to fix this. So I'm going to change the number at the top and bottom. So 2 should be 0 and negative 1 should be 0. Row 1 new. How do we make 2 0? Is 2 minus 2, right? So to make 2 minus 2 is row 1 minus 2 times row 2. How about negative 1? How do we make negative 1 into 0? Should be negative 1 plus 1. So row 3 plus row 2. Okay, so I'm going to erase this. And then, right, continue here. So since the second row, nothing changed and it's fixed, so we write back the second row, 3. So what is your new row 1? So row 1 minus 2 row 2. So now continue with the third column. So at the third column, negative 1 here should be 1, right? So how do we change that into 1? So row 3 new is negative 1 times row 3. So write back the other two columns. Zero, 1, 6, 3, negative. So this row 3 will be 0, 0, 1 and negative 2, 1, negative 1. Okay, right now, we're going to change negative 7 and 6 into 0. So row 3 is fixed. So fix row 3. How do we change negative 7 to 0? You know, because negative 7 plus 7. So row 1 new is row 1 plus 7 times row 3. Row 2 new is row 2 minus 6 row 3. So the only way to become 0 is to minus with the same number. Then we're going to calculate that. So now if you see, we have the identity matrix at the left side and then we have a new matrix at the right side, which the new matrix is actually your inverse, A inverse. Then we have A inverse equals to, okay, write back all the element, negative 19, 15, negative 2, 9, negative 7, 1, negative 7, 6, and negative 1. Done. Okay, so your task next is try and do part B, question B. So good luck to you.